Welcome, everyone. I am super happy to be here with you today. So the topic of today will be privacy-friendly advertising panel, and we will be talking about on-device anonymization. So advertising screens installed in public spaces equipped with cameras and other sensors are becoming more and more popular. They offer new ways of interacting with the panel while gathering useful metrics for advertisers. They allow them to count the number of passage made in front of the panel, measure the time of exposure, and automatically change the advertising screen based on the number of people that are passing by. However, many passerby do not wish to be filmed in public spaces, which is completely understandable. So this is why several companies have started to work on on-device anonymization techniques using edge machine learning. So for this workshop, Seed Studio, Soracom, and Edge Impulse have partnered to build this tutorial and to show you how to build a privacy-friendly advertising panel, including how to train a neural network using Edge Impulse, how to build a web application locally running on the Seed's recomputer Jetson, and then how to forward the inference results, including the blur or the anonymized image using Soracom. To get started with, I will pass on the mic to Hélène. Hélène is the global marketing manager focusing on Edge AI and partnership at Seed Studio. Thanks, Hélène, for being here, and I'll let you start.
Yeah, thank you, Louis. Yeah, I'm so happy to join this session with Louis and Nicholas to talk about building up this privacy-friendly advertisement panel. I think this is a very a good opportunity to boost the sales for the retailers, and that would be like bring up the Google Ads to the onside of the retailer stores. Yeah, and also let me share the screen to this and this session also using our recomputer of the JSON. So actually the recomputer JSON series is the whole product line to build up with NVIDIA JSON sums with the JSON Nano, Xavier NX, and also the OrangeX, the production module, and also with the seeds, the enclosure, the heatsink, and also the carrier boards. So on the top of the AI performance by the OrangeX, we're still working on that. It's gonna release very soon. So that is gonna deliver up to the 100 tops the AI, the performance. And also you can choose the Nano, the Xavier NX to tailor it to the different needs. So recomputer that is the small, the edge box can fit into the everywhere. The carrier board, the size actually right now is they're nearly the same as the NVIDIA, the official, the dev kit of the Nano and the NX. And also, which is more special, that is pre-installed the Jetpack, which means that it's more ready for the development and also the deployment that supports the JSON, the software, and the leading AI framework, and also the Edge Impulse. Because the Edge Impulse is fully support the NVIDIA JSON, you can directly add on a microphone and the camera to, and also seamlessly to build up a customer and a reliable model at the Edge Impulse Studio. And especially Louis gonna show the example like building up the model that's quite fast and a good inferencing at the edge. And also the recomputer that is comes with a rich set of the IOs with the gigabyte Ethernet, USB 3. So today Louis gonna show us is a 1020 comes with the full USB 3 and also the M.2 KE to powering the 5G or Bluetooth or the other communication modules, and also the M.2 KM on the back, and it can extend the storage with the SSD, and also the 40-pin GPIO to extend more possibilities. And furthermore, Seed also will provide further the customization on that you can pre-configure the software and also the hardware, the I/O customization, the service. Yeah, so on the right, there is also a webinar I have worked through the NVIDIA, the GTC, the March GTC this year, that is presented by the Cooler Screen. That is they are enable the customer a personalized the advertisement at the grocery store as in front of the cooler. So I think when we talk about the retail industry applications or the applications related to the face detection, actually for the privacy is always the priority we're thinking about, and also the connectivity, the security, that is all the main points our customers caring about when they want to bring the device pre-installed the AI to the edge. So I'm quite excited to this session, and so and also the Soracom's IoT, and they provide the secure and reliable the 24/7 connectivity. Yeah. So I will give my screen to Louis and to explain to Nicholas and Louis, and to go further on this step-by-step demo. Yeah.
Awesome. Thanks a lot, Elaine. Yeah, then we are now with Nicolas Deveau and Nicolas Lesconnec. I think Nicolas Lesconnec, you are going to say a few words. So Nicolas Deveau is a key account manager at Soracom, and Nicolas Lesconnec is a strategic partnership manager at Soracom as well. And we have actually shared a lot of things together with Nicolas, and we used to work together about 6 years ago now. Yeah, we're getting older. When we were working at Sigfox, an IoT company. And yeah, Nicolas was actually my first manager when I was working at Sigfox, and he's been a great manager, and I'm really grateful that we are working on this use case together again. Thanks, Nicolas, and I'm passing on the mic to you.
Thanks, Luis. Yes, so I knew Luis when he was a kid back then, and very happy to be here today for this webinar with our partners Edge Impulse and Seed. So to give you a few words about who we are and what we provide at Soracom in the context of this session, basically our role is to provide connectivity and connectivity services. So today's session will mostly focus on helping you create something. That's not what we do. What we do is once you detected events, you extracted the relevant information you want to upload to your cloud systems, we enable you to connect and to transmit those data efficiently. So basically what we provide, so connectivity with full MVNO capability, platform services, mostly upstream, be it at the networking level, application level with device management, provisioning, cloud functions if you need to sorry for that, compute your data on the fly, and some interface services that we'll see at the end of today's demo, mainly making sure that you are able very quickly to store and visualize the data that you're extracting from your application. So basically, once you found something clever or insightful that you may manage to extract from the environment, let's say by example, using Seed Studio hardware and Edge Impulse software solution, we will enable you to transmit that efficiently and do something with that data on your cloud applications. Don't worry, I don't have too much slides, Luis. I'll do it fast. So basically, you have your things, whatever communication they will use. So you may have noted the SIM card in my previous slide. So we provide cellular connectivity, be it 3G when available, LTE, LTM, NB-IoT, depending on the network availability all over the world. But we also provide Sigfox connectivity and basically connectivity for anything using IP-based protocol, so that you can forward into the same data ingestion pipeline and use the same Soracom tools, store them together, and use our visualization tool that you'll see a bit later on. And maybe a couple of words. So today is about privacy-friendly advertising. That's not exactly what I'm showing here, but in some application beyond privacy, what you'll need at the network level is making sure that you have private exchanges and that your data or your customer data does not go through the public internet. And that's part of what we can easily provide to customers, the ability to build fully private connections from device to cloud and the other way around, making sure that your data, that your application is first privacy friendly, but your data is also properly secured along the way and providing you top-notch security from device to cloud. So that's it about Soracom. Of course, if you want to learn more about the details of connectivity services, which are not the focus of today's session, or are willing to become a partner or a customer of Soracom, I'd be more than happy to have a direct chat with you. So we've got my contact details here, and otherwise you can just use the discussion window that you have with you. Thanks, and looking forward to the session, Luis.
Thank you. Thanks a lot, Nicolas. All right. So I will get the screen share. You need to unshare your screen first, I think, Nico.
And should be okay now, right?
Great. Yeah. My full. Okay, can I do that? Oh, advanced. Okay, I'm the only one who. Okay, let me stop and try to reshare. Okay, I think that should work.
Yep, we can see your screen now, Luis.
Okay, great, thanks. All right, so for the agenda of today, I will first go through different image processing approaches. So because when we need to anonymize the image, we need to go through a computer vision approach. Then I will show you based on the one we've chosen, which is called FOMO, which stands for faster objects, more objects. I will go through that in a minute. How you can build your own machine learning model. It's a custom one, meaning like you build it from scratch. Then I will show you how to extract the machine learning model that we built in the cloud and to take it and build an application that runs on the edge on the edge device. In our case, on the SIDS recomputer Jetson. And then I will show you how to forward the metrics with Soracom, including one people counter and the anonymized image. So we are going to use three tools mostly, Edge Impulse Studio, then the SIDS recomputer to host a web page. And finally, we are going to use a set of tools provided by Soracom to forward the inference. Just one, I've got only one slide about Edge Impulse, who we are. The goal of Edge Impulse is to go to market faster for you to build embedded machine learning solutions. And we cover everything from the data collection to the impulse design. The impulse is a bit of a mix between the digital signal processing and the machine learning blocks. And when you mix that together, you can build efficient embedded machine learning models. We also provide tools for you to test the machine learning models and a wide variety of solutions to deploy them on edge devices, whether they are MCU based, like ARM v7, like the Jetson, and other solutions. And then keep in mind that a machine learning loop, machine learning op, it's always a loop. So you go over and you iterate over time, and this is how your machine learning model gets better. So different image processing approach. The first and the most classical one is image classification. In that case, the model tried to answer a question, which is here in that case, is there a face or not in the image? Here it's a binary classifier. One of the most common use case is it a dog or a cat? So it provides interesting information, but in our case, you can only not send the picture which contain a person or a face. This is not great for our use case. So that's image classification. Then we have object detection using bounding boxes. This should be perfect because it provides both if there is a face, the number of faces, and especially the size of it. However, these models are extremely slow on edge devices. And then we have another approach, which is object detection using centroids. And here the model, the question the model is trying to answer is are there faces in the image and where they are. So we don't really care about the size in this case. We noticed with several customers that the size of the object in the image is not always as important as it seems to be in the first place. And what's behind this kind of model is FOMO. It's a brand new approach that we developed internally, especially Matt Kelsey. He's based in Australia. He's a ex-Googler and he's super brilliant. He's smart. So he came up with one idea, FOMO. So he wanted to be able to detect objects on MCUs. Detect object on MCUs is super hard, so it will obviously work on a Jetson-based computer. So what's basically behind the technique? I'm not going to spend too much time on the architecture because it can be quite complex, but we take the MobileNet V2 based architecture and we're going to use a pre-trained so transfer learning. So we will keep some of the weights. So in our case, we cut the MobileNet V2 architecture, keeping only the first weights, and we're going to retrain the latest layers using our own data that we collected. So again, what's behind what's the technique behind that is not the topic of that session, but just for your understanding, when we take an image, we actually divide it by 8 and we obtain a grid or a feature maps. And at the moment, the division by 8 is by default. You will be able to modify that in the future. So we obtain a 30 by 30 grid of 8 pixels each. And then we run a class prediction like the image classification for each cell. Let me take you with an example. Here you have a receptive field, so a cell, and then we will classify that. So is it either a background, a ball, a dog, or a toy? That's basically the idea. So the math behind that, so yeah, again, I'm going to take another example. It's probably going to be a bit clearer. So here it's a grayscale image, a 96 by 96. So we obtain a 12 by 12 feature maps of 8 pixels each. What we wanted to do is to keep the interoperability with other models. So we keep using the bounding box to label our images. So here on each region of interest, so the screws, we can draw bounding boxes. And then during the training, we will only train on the centroid. So only on the cell that is pointed on with a red dot. And we obtain a probability of class for each of the cell, and we apply some post-processing to get rid of the cells that are too close to each other, which could lead to the same objects. Note that this can lead to one limitation, is that the object that you're trying to detect, so for example, in our case, our faces, should not be too close to each other, otherwise they could be considered as only one, and the one with the higher probability will be kept. So the difference between the two, the bounding boxes using MobileNet V2, SSD, FPN, and FOMO, one is super fast. FOMO is really, it's great for doing real-time pre-processing. Both work with bounding box as a labeling method. One has a limitation, it only allows 320 by 320 input size, so images. The only limitation is that the image needs to be square. It can be any size. The MobileNet V2 SSD FPN use only RGB, where on FOMO you can use grayscale plus RGB. The output is bounding box on the one side, which is nice because you can get the size of the objects, whereas on the other one, it's only using centroid, so you only get the location of the objects. One can run on MCU and the other cannot. Both support GPUs. And why I have chosen FOMO for our project is also because MobileNet V2 SSD, although it works great with the Jetson, with the recomputer from Seed, the only thing is it tends to be way better at detecting object that takes a large portion of the screen. So for example, if you want to put your camera far away from the advertising panel, it will have trouble to detect small objects or smaller faces. And it also uses higher compute resources, so you cannot process as many frames per second as you would like. We are about, I think for the Jetson, recomputer something around 1 or 2 frames per second, whereas on the using FOMO, we achieve something like 35 or 40 frames per second, which is extremely fast. This is just an example on the that's on the Raspberry Pi. That's basically it. So if you want to learn more about FOMO, feel free to go on edgeimpulse.com/FOMO, and then I will go directly to the demo, because that's the thing that is going to interest us. So I built the tutorial. It's hosted on GitHub. So github.com/edgeimpulse/workshop privacy-friendly advertising panel. I'm actually going to copy paste the link directly in the chat. So it's going to be easier for everyone. If I can, where is that chat? And here you have all the tutorial that we created for you. So yeah, let's first dive into the topic. So that's the Recomputer Jetson that we're going to use. I love the form factor. It's great. It's really well designed. When you open the box, like you open a brilliant piece of hardware. And then on the left, you can see the Soracom dongle, which provides LTE connectivity. It has a SIM card in it, so the Soracom SIM card. Yeah, that's it. So that's what we are going to use as the edge device connected to a screen. And I also attached an external USB camera. I don't have any link, whatever a USB camera can work. And the first step will be to build your machine learning model using Edge Impulse. So to do so, I invite you to create an account on Edge Impulse. So edgeimpulse.com, studio.edgeimpulse.com. And once you're on it, I will actually start with a blank project, create a new project, so that I will show you how to get started and build a machine learning project from scratch. The only thing is that I will need definitely more images than what I can record in just a small session. So I will then switch to another project which is fully trained. But for the first part, I will guide you through how to do that live. So on device anonymization. I made a mistake. Anonymization. Okay. I create a new project, and when you're can you see properly, or you want me to zoom a bit my screen? I know sometimes it's easier. Okay. I think like that it's good, better for your eyes. So when you create a new project, you have a small wizard explaining to you or guiding you through which kind of project you want to create. In my case, I want an image project, and I want to classify multiple objects, which is called object detection. I'm going to select that, and yes, I know what I'm doing. Hide this wizard. That's great. So the first step is to collect some data. You cannot start a machine learning project without any data, because the machine learning model will learn on the data. So first, you can navigate to the data acquisition tab, and you have several options to collect some data. You can use your mobile phone directly by showing a QR code, so you can flash. Let me do that for you. You can flash the QR code and connect your phone. Does this work? Ah. Okay, Edge Impulse. And my phone should be connected. Get started, and then with my phone, I can collect different images. Like that, and probably will be arriving. But yeah, that's me. So that's one first image that I can collect, and I can also collect. Well, you can gather data from basically any source. If you've got some data sets already available in your S3 buckets, you can import that as well. You can use your computer to collect some data, give access to the camera, and then I can do the same. Okay, now I've got some pictures, so definitely not enough to create a project, but I have my first images. So I will need to label my data, because at the moment I've only got images and I don't have any information about the location of the face. So we provide tools as well to help you to label your images. So here in that case, I will just draw a bounding box around my face. I can set the label, I can save the label, and I can pass on to the next image. Do it like that. This process can be really tedious. So we have different tools to help you. You can track object between frames, or you can classify that using YOLO v5. The only problem with YOLO v5 is that the dataset contain, well, the labels contain label person, but not face. So I won't be able to use that to label those faces. So again, on this project, I'm just labeling a few images of my face for the model to work good on a wide variety of person. It's really important that you have a diverse data set, diverse and ethic data set, meaning like you should have the same number of male versus female, of like white people versus black and other ethnic, save labels, and yeah, that's really important if you want to have a production model that goes live. Then once you have your dataset label, so here in my case I've only got 5 items, so it's definitely not enough. Those data are put in the training sets. You can also put some data in the test sets, which is not going to be used to train the model, but we are going to use that later to test that the accuracy of our model. Now I'm just going to quit that project and go back to the other one that I created for you, which is called FOMO, I think FOMO bigger dataset. On this one, so I've used a subset of the FFHQ dataset, which is provided by Flickr. It's an open source dataset that we can use. And if you go in the data acquisition, you can see like the different faces that I have. I also collected some faces of my colleagues to do so. Yeah, so this data set is a mix of open source data set and pictures that I collected myself. Yeah, that's again me, and that's another thing. So once you have like, at the moment I've got 400 items in my training data set, and I've got something like 100 items in my test data set. Now I've got enough data that I can move to the create impulse tab. This tab is super important. It will create your machine learning pipeline for you. So for this case, I'm going to use a 96 by 96 images. So all the image that I've got in my data acquisition tab is going to be shrinked before passing that to the pre-processing. In this case, the pre-processing is not super complicated because I will keep the RGB images. Then you can also select a wide variety of pre-processing. Here, it's only the one available for images, but if you're working with other kind of machine learning model, we have different things for audio, spectral analysis, if you're trying to recognize movements, a spectrogram, again, for audio and different things. And you can also use only the raw data, meaning in our case, only the pixels, if you wish. I'm going to stick with the image one. And then I'm going to use an object detection model that I've selected at the first step when I created the project. And I can save my impulse. Once your impulse is saved, it means like your pipeline is created. You can navigate to the next tab, which is the image one. In that case, it's going to be the pre-processing. So it takes the raw features, so those are the pixels of the image, and it will pre-process the pixels, so it will be easier for the neural network to ingest and to learn on. So here, I'm pretty sure it's just doing kind of a normalization on the pixels. I can check with one image, I can check with another one, and it goes from here to here. And I can save the parameters and I can generate the features. So when you generate the features, it will extract or convert all the pixels to the normalized array that the neural network will be fed with. And you have some information about the on-device performances, whether and also the processing time and the max power resource consumption, in that case, the RAM. Great. So here I've got only one class, I've got only the faces, but if you have got several, it's a good idea to just check at the feature explorer just to see if you can start to distinguish some clusters. If so, it usually means that the neural network will likely learn efficiently. Once done, you can navigate to the object detection tab, and that's the machine learning part. So you can set the number of training cycles, the learning rates, which are the hyperparameters for your machine learning model. You can set the validation size. So when you have your training data set, you will need some data to establish the weights, and you will need to test those data on a validation test, which is different from the test data set. The test data set is kept apart during the whole training process. This one, the validation set, will be used to just adjust the weights of your neural network. Do we want to use data augmentation? Yes, that depends on the use case, but in our case, that's preferable. And then we have several options in the object detection use case. Use case. Either the MobileNet V2 SSD FPN Lite that I talked to you about before, which will provide the size of the object, or only the FOMO. We have two alphas here. I think I've used the one with the higher alpha. That's not a big deal. One will be probably a bit less accurate, but will be also a bit more lightweight. So then you can click on Start Training. It will take a few minutes. And after that, you will obtain an F1 score. Depending on, F1 score is a good metric. It's probably not the best one, but in our case, that's enough. So we have two versions of the model that is being created for you, one quantized version and one unoptimized. So the quantized use int8 and the unoptimized use float32. I know that the SIDS recomputer Jetson is way too powerful to use only quantized, so I can use the unoptimized one. That's great because it provides a better F1 score. So here, if I have a quick look at the confusion metrics, the background is almost always properly recognized, and the faces, I've got an accuracy of 84.6% based on my data set that I trained it with. So I consider that for a workshop and for a first proof of concept is more than enough to continue. I can make sure that my model is good enough, so I can click on classify all, so it will run the inference across my test data set, and with that I can make sure that the model has not been overtrained. So here I've got a lower accuracy, so an accuracy of 73.5. It's not great, but again, for a small data set containing 400 images, I consider that's good enough for what I want to do. Then you can version your project. You can make it public if you want. This project is public, so if you want to have a look at it, you can open the public version. I will copy paste as well. It's on the chat, so you can. I'm not sure. Can you host and panel? Not sure if you can see the messages I'm copy pasting in the chat, but let me know if not. This project is public. You can clone it and get started from there. You can do that. So once I've done that, I can navigate to the deployments, and we have several options to deploy your machine learning model on edge devices. Most of the people use the C++ library when it comes to MCU, when it comes to deployment on MCUs. And on our case, we are going to use the Linux boards So for that, you need to install on your Linux machine a command line interface. So it's a Edge Impulse CLI for Linux. It will automatically detect which kind of architecture are you using, and then how to download the thing. So that's what we are going to do. I'm not going to switch right now on the Seeds recomputer. I'm just going to show you how to do that, how to use the CLI interface using my MacBook Pro. Here, I'm just going to. I'm not sure you can see my terminal, so I will just unshare my screen and share it again. Stop sharing. Maybe if you have a few questions, I can take some of those right now before moving to the next parts. So feel free to ask questions either in the chat or in the Q&A. No questions so far. Okay, well, I'm just going to continue. So share screen and can I share my entire screen? I don't think I can. So I will do that in 2 steps. I hope you can see my terminal. I'm just going to zoom a bit. So to download the Edge Impulse model from your CD workshop. Space workshop. Soracom. Yeah. Okay. You need to use the CLI command line interface, so Edge Impulse Linux runner, and then you can. Well, I'm just going to do that and clean it. It will ask me for my credentials. So Louis, /demo. Great, and this one is the one that I want. I can use this one, and it will open up a new, or it will create a web application. So this one at the moment is only running on my MacBook Pro. It's exactly the same procedure if you want to run it on the Jetson, on the Seeds recomputer Jetson. As you can see, obviously on my Mac it's super fast, but you can detect my face easily. It has a few, like here, for example, sometimes my fingers are recognized as a face. That's funny. So maybe some of the images in the training set are people having their hands around the face. That happens. You just need to have more data to make it more accurate. So that's, oh no, sorry again, you cannot see my screen.
Yeah, I was about to say to you, Luis, when you show us your console, we cannot see the bounding boxes.
Yeah, I cannot share my whole Chrome. Can you see them? Yeah, okay, awesome.
Yeah, right now it's good.
Okay, so yeah, that's my face. That the model that has been trained. It's completely running. So at the moment locally, but still on my MacBook Pro. I said that some of my fingers are recognized as a face, so that's a false positive. I said that it's probably because some of the pictures in the dataset have been trained like when we drew bounding boxes around the face, you might have had a hand, so it like recognize some of the fingers as a face. That's not a big deal. If you want to get over it, you just need to have more pictures in your dataset.
And how many concurrent objects can you detect on a single frame?
So on a single, so on a 96 by 96, as we divide the height and the width by 8, you can only have 12 by 12 max, which is 144, if I'm not mistaken.
That's it.
Yeah.
Okay, thanks.
Obviously, we have I think we have a limitation in our SDK for the C++ deployments because most of the targets, like the MCUs, won't be able to support those. So I think we limit up to 10 or 15 objects, but this can be changed if you have a more powerful thing. Not at the moment I've only got my face, but you could have, for example, my face plus a dog face, a cat face, which can be 2 or 3 different labels. Okay. Actually, you can have a car, a truck, and a person, for example, or a bicycle, and those can run at the same time.
Okay, great, thank you.
All right, so let me just go back on the tutorial. Pre-process your image, so that I've explained to you. And yeah, this is what I've just shown you with my terminal, Edge Impulse Linux runner, clean. You log in your account and it will automatically download the Edge Impulse model for you, which is it will automatically detect which kind of architecture you have. So in the Jetson, I think it's a ARM-v7 architecture in the C3 computer. And yeah, this is what I've shown you. On this screenshot, I was using grayscale images. I noticed that the RGB one worked better, so I decided to switch it for the project. And then I'm just going to give you a heads up on how you can integrate this model using our Python SDK. So to create an application from scratch. To do so, you can have a look at the so GitHub.com Edge Impulse. I think it's Linux Python SDK. So this is an example. This repository contains several examples on how you can do that. So on images, I've mostly reused most of the probably the classified.py for the project. And I want to go through the custom code that we wrote for you, which is here, the application.py. It only contains like 200 lines of code. So as you can see, the application is really easy. It also includes a small web page that you can find in the template. So index.html. That will be the rendering for this, or that's image with background, index with background. That's basically, it's not super complicated. So it has a header, a title. This is a background, so an images, and this is a live stream. So I'm live streaming different advertisements. And here you have another live stream, which is the pre-processed, which is the camera feed after the pre-processing, after the post-processing, sorry. So it first detects the face, and then I'm going to show you how to blur the face on the small application.py. So it has been written in Python. Note that we have also SDK for Node.js, I think for Go. Well, we have several depending on what language you're familiar with. Feel free to use them. So what's interesting in the code? So I'm not going to go through all the line of code. I'm just going to explain to you how you can retrieve the model that you downloaded through Edge Impulse. So this is the model file that you pass as an argument. Then you initiate the Edge Impulse runner. You just declare you initialize your camera, and then you pass the image, so the frame of your camera, into the classifier. This we don't care because you are not using classification, but we are using object detection, and that's actually all that all the processing is done here. So we just set a buffer to count the people. We set the inference speed, which is displayed as well on the web page. And then for each bounding boxes, so for each object that has been detected, we check the values. So if the value here it's above 0, okay, so we don't take any. For example, if you're having too many false positive, you can set the threshold to be a bit higher. And then we just add the count people, we increase the counter. And the mask is actually done here. So we take the image, we create a mask, and then we blur the mask, and then we reapply that to the image. And that's the image that is going to be displayed. It's also the image that is going to be forwarded using Soracom. Okay, so great. Just enable the flag if you want to use Soracom, then created a function send the inference and then send the image. We are going to see that in a minute. And so send the inference. So yeah, okay. I'm just stopping that for a sec. And I'm going to introduce, I'm going to show you after on the Jetson what it's like, but I need to unplug my camera. So I'm going to do that after, otherwise you won't have the return on the video. And how to send the inference result with Soracom. So when you order the USB dongle, like this one is called I think it's called the Onyx LTE USB dongle. It's provided with a SIM card. So usually when you order one, you have an account set for you, and you will find your SIM card directly on your account. I'm going to go to console.soracom.com. Just open a new this one. I won't be able to. Okay, let me do that. Console.soracom.io, if I'm not mistaken. Oh, great. It's already, credentials already saved. So when you create when you order a SIM card, usually you already have one SIM card that is associated with your account. Feel free to correct me, both Nicolas, if I'm wrong. I don't think I had to activate it myself, except maybe sending or connecting it through my laptop.
You may have got some premium onboarding process, Luis.
Okay.
Anyway, onboarding is usually pretty smooth and fast, so no need to elaborate too much on that.
Okay, great to know. So we are going to use 3 things from Soracom. First is the data connectivity and the messages, so just like the internet connection that we are going to use. And then we are going to use Soracom Harvest and Soracom Harvest files. So it's no, Harvest data and Harvest files. And to enable those, you can go to your account, and then you can go to the groups, Edge Impulse group that I created before, and you can enable both the Soracom Harvest and Soracom files. So the Soracom Harvest data will just enable you to collect some objects. In my case, it's just a people counter, so basically an object that I pass in the code, which is here. The object is count people and count people. This is only what I am going to retrieve. And the Soracom Harvest file, it's the blur images. And you need to enable that as well. You have a few configuration to set in here. It's all written in the tutorial. And once this is set, you can navigate and go to the data storage and visualization, and you can check the data, which none of those are present here. Let me auto refresh, and I'm going to open up just the recomputer Jetson, which is behind me. I just need a second to do that. Unfortunately, I will need to unplug my camera so that it can work. I just need 1 second. I know it's not the smoothest. Okay, let me do that.
Luis, for your information, you did not select any resource in the top left drop-down menu, so we might not see the incoming data that way.
Oh,
I think
correct.
you should select it.
Okay, thank you. So that's this SIM card.
And
Okay.
here there.
And here we are. Okay, so I've got okay, I can open the 92 point. Let me just check that 1.16. 15. And this is the application that is running, okay, on the Jetson. So you can see my back. Okay, that's me. So yeah, when you recognize 2%, you just display another ad, and that's me. And there. So we have a few false positive, which is not a big deal. Okay, so now you saw that what is happening. You can still see me. Oh, here we have got an issue. Okay, that's not a problem.
Sorry, Luis, a quick question. This amount of false positive, you think it's mainly due to the quality of the trained model?
Yeah, definitely. A big, for example, I've just set up the screen behind me, so I haven't tested the model before the workshop with this location. Which is good with Edge Impulse is that you can create custom models. For example, you can adapt the model based on where you want to put your advertising screen. So if you want to put it in a street, you can retrain only one model. So take a general model, but retrain it with that background and that street, so that you will, or that camera angle. So you will know it will work good in that condition. If you want to work or to create a model that is super general, in that case, you will need much more data than only 400 images, or at least some data that are that are more various than the one I've used.
Okay.
Actually, I can. Can you start video? Oh yeah, I can forget that my laptop had a camera as well. So that's great. Now the model is still running. So I'm always forwarding the people counter, so the number of persons detected. That I am forwarding that every 10 seconds, and the frames I'm sending them once every minute. So that's good. And once I've got the information coming in Soracom Harvest, I'm going to use one of their tool, which is great. It's Soracom Lagoon. Basically, it's a Grafana, but already plugged with what you can receive. I'm going to go with to my account, and oh yes, I've got that. Oh no. Let me just. I need to find the password. Okay, I'm just going to. I believe you cannot see my screen now.
We can see you on the Lagoon login page at the moment.
Okay. Okay, I've got another. Sorry.
Yeah, so Lagoon being a dashboarding tool that can be used by other members than the one accessing the console. It has the different credentials, so maybe you only have one stored in the browser at the moment. Might be quicker to do a password reset at that point.
I think.
Oh.
No. What I will do is just unshare my screen and share it again with the right page. Which one are you seeing right now?
Still Soracom Lagoon login page.
Oh yeah, that one, login. Here we go. Okay, so now it's not seeing anyone. Let me just go back and try to show my face. Hopefully, arrive here. Oh, I may need to refresh. 3 minutes. Okay, so that's the demo effect. I'm not sure why it's not forwarding the results. Let me try that again. The model is seeing my back, so probably it has to do with that. So know that all the pre-processing, all the processing is done directly on the JSON. So okay, I'm going to stop sharing and then share again the other.
Yeah, we saw on the chart that there were
Some data coming in.
Yeah. We saw the chart going up to 2 and then getting back to 0.
Okay, I'm just going to share again that screen. It's the one that you can see. So here the false positive. Know that also the way I trained the model is I've made sure to be as far as possible, well, not as far as possible, but at least 1 to 2 meters away from the camera. So if I'm too close to the camera or too far away, the model has not been trained in those conditions. So that's probably why you have false positive. And indeed, I haven't tested in that configuration with the new setup on my back.
Yeah, sorry, Luis, another question. For the purpose of the demonstration, has the model been trained on detecting your face, or would it detect any human face, whatever the age, gender, ethnicity, or whatever?
So let me go back to this one. So the Flickr, the FFQ
that's also including all the kinds of the face. Yeah.
Yeah,
So
exactly. So this one is really good because it's pretty various. I've only taken a subset because this one contains millions of images. So I've only taken a subset of it. And I've added some more images of my face. So it's better at recognizing my face and the faces of some of my colleagues. I'm not sure. Yeah, that's David Tischler. Yeah, that's some other colleagues, Omar and Nabil. So yeah, obviously our company is not the most diverse one as any tech companies, I would say. Yeah, but at least on those ones. I also tried like with my newborn kid. It works well. It can recognize him pretty.
Oh.
Good.
Pretty well. Yeah, that's the images. I tried to only use the images that take like looks like 1.5 or to 2 meters away from the cameras. But obviously this is for demo purpose. Otherwise, I'm pretty sure for advertising cam you need to have a camera which is way further, so the faces will be way smaller. But you can use some other. You can use some more. Sorry, some bigger images. I want to check Lagoon again. Okay, so it come back. I'm going to stop sharing and share again. Share screen. This one. Sorry for the back and forth. So yeah, you can see that every X seconds we've got some new data coming in, and I wanted to have the. I'm not showing my face. Okay, so it's not showing my my face, which is blurred, but it's actually exactly the same as the one you've seen, like with a gray with a green round, which is blurred. This is really nice because by doing so, you can use those anonymized images and take one step further the post-processing. For example, if you want to understand how long the people have been in front of the screen, or how they interacted with it. Did they stay for a while? Did they looked intrigued about the advertising screen? That's things that you can do. Same for if you want to analyze in the supermarkets the consumer behavior, and you want to do that, but you don't want to collect the faces. You want to have an anonymized images. You can do you can apply the same techniques and apply that to video surveillance or like dedicated images. There are different techniques that exist to blur or to do on-device anonymization. At the moment, most of the technique is done in the cloud. So I've seen a lot of videos of anonymization techniques, but by doing so on the device, it really brings the privacy one step further, because image cannot be retrieved in any way from any application or any other AI algorithms. That's it for me for today, for this workshop. I hope you enjoyed it, and I would be really happy to to answer any question that you might have. Yeah, feel free to shout. Nico, you had quite a few questions. Do you have any others that I can get
No,
you
I gave it all during the presentation.
All right.
Oh, I have a question, Louis. I want to know, is that possible to, like, for when we're building the advertisement, can we like detecting the just differentiate the people like from the maybe the age or the different group of people to setting up the different personalized the advertisement, but at the same time that is also the blur the face that's possible to run the just like the setting up the run the different models.
Yeah, that's a really good question. Indeed, we can do that. The only thing is, I know that it has been these kind of techniques has been criticized a bit by the public lately. How to differentiate even like emotions. I've seen some, because Microsoft had some great algorithm quite a long time ago, and I think they decided to just stop it because it was being criticized in some way. So I didn't want it to go in that direction. I think you need to think twice about what you want to do before doing so, and make sure it respects, because I'm not really sure if you want to display, for example, with the kids, an advertisement of toys versus adults, an advertisement of a toothbrush. I'm pretty sure it's not a big deal. But if you're mistaken about a kid and an adult, then you need to think of what's the consequences of it. This example is pretty easy, but same for gender identification. Yeah, and I don't want to enter in that in that space. It's possible, but we need to think ethically about what we want to do.
Yeah, cool. Yes, and also like for the the tennis and for the registers, we also posted on our social. We will also give away when the recompute J1010 that's powered by the Jason Nano. But that is start from the $199, and it comes with the three to the USB 2 and one the USB 3, and yeah, this we're gonna give away that after this webinars. Yeah.
Oh, that's great. And now that I finished the demo, I'm actually going to unplug it and show it to you. I really love the form factor of of the Jetson, of
Thank
the
you.
computer. Yeah, it's looking like that, and yeah, I love it. It says every connectivity except maybe Wi-Fi.
Actually, you can just if you add on the Wi-Fi module, that you can enable that. Yeah. And so, and when you press the button at the bottom, and you're gonna open the box and see.
Oh yeah,
the
that's
yeah.
And you can easily open it.
Just push.
It's
up
magnet,
that.
right? I think it's
Yeah,
brilliant
yeah,
the way you
magnet.
can open it. Just
Yeah.
a magnet.
Yes, correctly, exactly. Yeah.
Anyway, yeah, it's a great product. I think I will leave it on the screen, like on the setup over there, and test different things on it. If you want to install and make it ready to be compatible with the Edge Impulse, we have a documentation web page under the community board. Feel free to have a look. It's all explained how to do so, how to set up the recomputer from seed. We've done that work a few months ago with Ellen.
Yes, and also we have another example for detecting the helmet detection for the construction, the scenarios. Yeah, also using the Edge Impulse. Yeah.
Great. Well, if there is no other questions, I wish you a very good day, evening, or probably night for you as well, Elaine. What time is it on your side?
The midnight. Exactly.
Okay.
Yeah.
Thanks for being stayed up late for us, and I wish you a very good day and very good night. Bye bye, everyone. It was a pleasure to have you.